coordinate in various national and as well as international training programs, Green and Eco-Friendly Movement Certified Professional, GEMCP. It is a training to international participants of Ministry of External Affairs, Government of India. Delivered invited talks, guest lectures, visiting faculty to universities or industries, and is expert in technical team in International Solar Alliances ISA. He is working in various international collaboration projects on NISE with the NREL USA, AIST Japan, STAPP project Indo-UK, SCRII US, Indo-US. So with this introduction, we are welcoming you, sir. Please hand out the session and give your valuable inputs to our participants. Thank you, sir.
Thank you very much, sir, for inviting me this talk, and I'm very, very thankful to Ramchand, sir, and the another sir who is invited me for this very nice platform. So I just share my screen with you. Yeah. It is visible for everyone.
Yes, it's visible, sir. It's visible, sir. Yogesh, sir, it's visible.
Yeah, sure. So I just going on. So thank you very much. And now we will start our session. So in this session, we will discuss about the different type of testing on a solar PV module. So my name is Yogesh Kumar Singh. I am a director in MES CAT Private Limited. I am also the solar scientist and solar expert. So what is the outcome come from this session? By the end of the session, we will cover the standards of the PV module. What are the major standards are applicable for in a PV industry? Then we will discuss about the reliability of the PV testing in a PV module. Then we will cover the qualification testing. What are the qualification testing is required for any module? Then we will talking about the sampling of the module. Then we will discuss about the pass and fail criteria of the module. So what are the major criteria? How you decided that this module is a pass or in a fail criteria. Then we will discuss about the sequence of the qualification test, how the test will be done there. Then we will cover the visual inspection and other thing. Then we will discuss about the maximum degradation of the module. Then we will cover the performance of the measurement at the STC condition. Then we will also discuss about the characteristic of solar IV curve. Then we will discuss about the insulation resistance and the electrical safety test from the module. Then we will discuss about what is the effect happening in the low Elian's performance on the module. Then we will discuss about the bypass diode and the thermal tested. And then we will discuss about the hot spot endurance test. What is the hot spot and how can you test this type of things in the module. Then we will discuss about the UV preconditioning test, and finally we will discuss about the thermal and humidity sizing. So these all are the topics we will cover in the session. So we first cover from the standard for the PV module. So what are the major standards are they required for the PV module testing? The first standard is the IEC 61215. The IEC means the International Electrotechnical Commission, and this is the international certified body. So whatever the module or the component or the BOS system are made by the solar industry, all are the component are certified by the IEC standard. So when we talk about the PV module designing and qualification, and especially for the crystalline technology, because when we're talking about the technology is basically the two type. One is the crystalline technology and another is the thin film module. So when we talk about the crystalline module, there is a two category. One is the monocrystalline and another is the multicrystalline or polycrystalline technology. So and when we talk about the thin film, so there is a different type of technology like the CDT, CIGS, amorphous silicon, micromorph and other things. So whenever we testing the module for the crystalline technology, so we will cover the IC 61215. When if we testing in a thin film technology, so the IC 61646. And another IC for the measurement of the photovoltaic current and voltage characteristic. So we will follow the IC 60904-1, and in IC 60904-2 is the requirement for the reference solar devices. The reference solar devices basically useful for the the giving the reference condition from the another module. So with the help of that reference module, we will testing our original module. They have given the proper output or not. Then the IEC 600904, which is basically the part 3, which is basically cover the measurement of the PV solar devices and the reference spectral irradiance data. So the spectral irradiance is also important for the module. So we will discuss on the slide. Then in a 60904-6 is the requirement of the reference module. So initially we will doing through the reference solar devices, and then we will discuss about the reference module. In the 90904-7, we will discuss about the measurement of the photovoltaic devices. So what is the spectral mismatch correction will be happening. So that spectral mismatch correction will be coming on this IC 90904-7. If you want to the spectral response of the PV devices, so we follow the IC 90904-8. If we want to the simulator performance, because every module have the tested by the IV simulator, so for the solar simulator performance requirement, we will follow the IC 90904-9. And if we have want to check the linearity measurement, so we will just go for the IC 90904-10. And if you're talking about the safety and the qualification testing, so that's the IC is a 61730. There is a two part. One is the part 1 and part 2. So with the help of that part 1 and part 2, we will cover the safety thing. Then we have the salt mist test. Basically, we have doing the salt mist test in a different condition, because when the module are putting in any coastal area and the sea area, so the salt will be taking the major concern in there. So that is the salt mist testing will be done by this IC 61701. And finally, we have the photovoltaic module for the detection of potential induced degradation. That is called to the PID. So the PID is a major term. So with the help of the IC 62804, we will done the PID testing. And what is the meaning of PID? When the module are cleaning in any salty water, or sometimes the ground fault will be happening there. So in that module, some leakage current will be grown on the module, and once the leakage current will be grown on module, their shunt resistance will be reduced. And once the shunt resistance will be reduced, the module fill factor is automatically reduces on that condition. And that, in the resultant, what happens to your overall power will be affected on that particular condition. So that is the PID test. Now we come to the second part. What is the reliability of the testing of the module? So in order to assess the different type of module, and so with the defining of this thing in IC 60721-2-2, so the reliability of the module, basically when we talk about the module lifetime, so module are working in a 25 years as long as period. So whenever you purchase a solar module, each company give the guarantee to you, your module will be working in a 25 years. So for the reliability kind of things, and when the module are exposure in outside, so that's the reliability is very important, and that reliability testing is much more important for the solar module. Now, when the actual life expectancy of the module, however, depends the environmental condition. So that is also the important, because a lot of time the environmental condition is affected to the module behavior. Then the PV module required the short pressure conditions to the period of the 20 to 25 years without the degradation in the less than of the 10%. So there is a one degradation kind of unity. So the degradation will be happening on the effect of the power, current, fill factor, and the another parameter. So if your module is a crystalline technology, so the degradation rate will be happening around 0.5% in a year-to-year basis. And if your module is the thin film technology, so the degradation rate is higher, around 1 to 2% in each year. So suppose that if you purchase the 100-watt module in a today date, so after the 10 years, the module degradation will be happening at the 10%. means the 100 watt module is given to the 90 watt in after 10 years. And when we talk about the 20 years reliability, means if the 100 watt module, the today date it will be given the 100 watt. So after the 20 years, it will be only give the 80 watt of the output. So this is the criteria for the deciding on the reliability of the module. Now we talk about the qualification of testing. So the lot of the qualification done, the testing will be happening in the different laboratory. So initially I am working the National Institute of Solar Energy. So we have the different type of facilities there, like the thin film module and other thing. And apart from that qualification testing, we have a different type of environmental condition and prologue, and that will be the for the module. The IV characteristics. So we have the size up to around 3 meter by the 3 meter. So we have that much of the area. If we have the module dimension is a 3 meter to 3 meters, so we will also take the IV curve of that particular condition. Now the sampling, how the sampling is the important when the manufacturer has submitted. So the module, so any laboratory or anything, they have brought it to the 8 identical kind of the thing. So always they want to the 8 different type of module is there, and that from the that will be taken from the production batch, and that will be taken by the randomly. So there is a no the rule, the all the module will be selected by the random basis. The modules shall have to do the manufacture from the specific material and components in accordance with the relevant drawing process and other thing. And the module normal inspection and the quality control and the production from the acceptance procedure from there. So these all are the things we will cover on that particular area. The module shall be the complete in every detail and shall be the comprise the manufacturing, handling, the mounting and the connection instructions. So whenever you put it whenever you take the module, the manufacturer will be give you to the all the instruction, all the guideline about the module. Then each module shall carry the clear and indivisible marking. So whatever the marking is required, the major marking like the name, the monogram, the symbol of the manufacturer, then the type of the model number, then the serial number, maximum system voltage for which the module are working, and the suitable. And so these are the things will be coming in the sampling. So this is the sampling criteria. So before module, the sampling of the module is a much more important parameter, and that's the sampling of the module. Any manufacturer has submitted to the 8 identical module in the laboratory, and that identical module have taken this type of information like the name of the module, name of the manufacturer, the types and the model number, then the serial number, the maximum system voltage, the module suitability of the system. So these all are the detail are the given on the particular module. Now the another criteria is the pass-fail criteria. So whenever the module are the testing in the environment, the STC condition. So I will be cover the what is the STC condition. So the things is pass-fail criteria. The degradation of the maximum output power does not exceed around the 8% after each test sequence. So suppose that the module is the 100 watt. So the only the 8% of the degradation will be affected on the final output. If there is a more than 8% degradation, so that is the sample will be not pass on that condition. And the final light soaking, the maximum output power STC is not less than the 90% of the minimum value which is the whichever the manufacturer given by the IC 61646. So if we taking the thin film module and when all the criteria will be done it, so the STC is not the power of the STC like the Pmax in STC condition is never ever less than in the 90% in that particular case. So if the module is failed below the 90% means the module will be failed on that particular condition. The number of sample is exhibited and in open circuit during the test. There is no visual evidence of the major defect. So these all are the things. Then the module will be selected. So there is no major defect like that. So a lot of time when you see the module, so the corrosion will be happening, the delamination will be happening. So this type of visual evidence is not happening on the module. The insulation test requirement are met after the test. So after all the doing the test, the insulation test is also requirement on that particular condition. And also the insulation test is the two type, one is the dry and another is the wet. So the wet leakage current test requirement are the meet to the beginning, and the heat is sequence after the damp heat test and the specific requirement for the individual test meeting. So these are the criteria will be requirement is there, and then the specific requirement for the individual test and the meet. So this is also the important criteria for the deciding of the pass and fail criteria of the module. Now we come to the test sequence for the qualification test. So what are the qualification tests will be coming? So the first thing, we have taken the 8 module. Then the module will be go to the preconditioning unit. So in the preconditioning unit, I will explain you in a further slide. So the each module will be put in the 5 kilowatt hour per meter square of the insulation. Then after one module go for the visual inspection, the 2 module will be go for the maximum power the determination. Then the third is the insulation test, and the 15 we will take in the weight leakage current. Now here the module will be distributed in a different way. So the one normal module will be taken from the final output type of the thing, but other one module will be go to the temperature coefficient test, NOCT test, performance of the NOCT test, then the performance of the low irradiance, outdoor exposure, bypass diode and hotspot, and then after we take the final output. Now the 2 module will be go to the UV preconditioning test. So in that particular condition, we have a required one environmental chamber, which is the UV chamber, you can say that. Then we will go to the thermal cycling test, and here we do the 15 different type of the cycle, and the temperature is a minus 42 plus 85 degrees centigrade on that particular condition. Then we will take in the humidity freeze test, and after that the 2 module will be taken. The one module will be go to the robustness of the termination, and the another module will be take to the final weight leakage current test. Now the another 2 module will be go to the thermal cycling, and this cycle will be given around 200 different cycle, and after the 200 different cycle we again take the STC condition of that particular way. And the last 2 module, in the 8 of the module, the last 2 module will we go to the damp heat test. So we have taken around the 1000 hours of the damping test. Then we have go to the weight leakage current, and from this particular weight leakage current we have taken the 2 module. One module will be go to the mechanical load testing, and another module will be go to the hail testing kind of thing. And finally we have a repeating this all the conditions. So after fulfilling the all the module and all the condition is there, so if the degradation is not happening in the 10%, so your module will be passed. If the degradation is more than 10%, so your module will be fail on that particular condition. So this is a test sequence is very important for the qualification of any solar module. Now we understand what is the condition and how can we will do it from this chart. So now we will come to the first condition, the preconditioning. What is the meaning of preconditioning? The preconditioning means you put your module in an open circuit condition, and you will be putting your module around 5.5 kilowatt hour per meter square on the condition, and there is no requirement. So this the upper requirement is only for the crystalline technology module. But if you have the IC 61646 like that, the thin film module, so there is no such kind of things will be affected on the system. And that the preconditioning having the different thin film technology, some thin film technology the more sensitive to the light induced degradation, while the other the more sensitive to the dark heat effect. So for the thin film module, we have using the light soaking of the system, and all the system are coming to the environmental sequence and then control sample and the measuring final Pmax to the just the weather condition. It is accepted with the reference to the related maximum value Pmax. So these are the condition is a requirement on that particular object. Now The first condition is the visual inspection. So what is the meaning of visual inspection? So what is the objective? So objective is that to detect of any visual defect on the module. So in the first thing in a visual inspection, we take the following things. We take the arrangement of the inspection of the module under the illumination of the 1000 lux. Then we will go into the microscopic careful inspection of the record if any crack and the broken cells will be find out, and any interconnection or the joint tackle, the plastic material, the cell touching the frame and other things. So we will just cross check this type of condition, and if we find any such type of condition in an initial stage, so we will just cross check, and we will not given into the further condition. So after the module will be fulfill the visual inspection, that it will be go to the next stage. Now we have the 5 major different defects will be finding on the crystalline module. The first defect like the broken, the craze, the then we will also cross check the banting on the misleading of the external surface, including the superstrate, the frame, junction box, and the another criteria. The crack of the cell propagation, which could remove more than the 10% if the module, if you find out any crack on the module and the cracks is the more than 10%, so that module will be also the fail on that particular condition. The avoid the visible corrosion on the thin film layer of the active circuitry of the module is only for the 10% of the availability. The bubbles and the delamination. So a lot of the time you will see the module have getting the bubbles and the delamination kind of the factor. So these are the factors also not included on that particular thing, and that the lose of the mechanical integrity which is extend to the installation of the operation of the module which is the impaired. Now the module marking and the label are no longer a test of the information is the unreadable. So this is also the important. So we will also cross check all the information like the sticker, the model number, serial number, everything will be matching on that particular the system. So these all are the visual inspection criteria. Now we will discuss about the degradation, and the major degradation will be happening in a PMAX. So how can we decide it that if we have the crystalline technology module, so we already discussed you the degradation is not happening in a 5% in the initial degradation in a single test, and not more than the 8% after the each test sequence. So if you qualify your product, if you qualify your module in IC 61215, so that is the two condition will be always follow on there actually. Now how can you define to the degradation value? So you just take the two value, one is the power in the initial basis and the another power is the final basis. So if you initial minus final divide by the multiply by 100 divide by the P initial value, so you can find out the degradation of the module. So suppose that if you have the 100 watt module, so initial you have got in the 100 watt, and the final, if suppose that you can take in the outdoor condition and finally you take the 90 watt, so 100 minus 90 is the 10, and then again you divided in the 100 in the initial way, so that is the 10% kind of thing. So that is the very high the response. So that's the condition. If your module is the 100 watt module, so only the 95 or 96 watt will be given on that particular condition. So that is the formula. With the help of initial and final value, we will calculate the degradation of the module. Now the similarly, so for the thin film module, we define the minimum Pmax, which will be around the Pmax plus minus the T%, and where the T is indicated to the production of the tolerance. So the each module has some tolerance value. The initially the tolerance is the plus minus 3%. Then after the tolerance will become to the plus minus 5%. But nowadays the tolerance will be come to the positive criteria. So there is a no negative the temperature coefficient. Everywhere we have find to the positive temperature coefficient. So whatever the module you are using, you will find out the positive temperature coefficient on that particular condition. Now we will discuss about the typically the performance parameter. So we have the two condition. I will explain you in the slide. So we have a two different condition that is called to the STC and the NOCT. So the STC means the standard test condition. So in a standard test condition, we have a three different condition. Like we have a irradiance. If the irradiance is 1,000 watt per meter square, your temperature is a 25 degrees centigrade, and that is the cell temperature, like the module temperature. And if your air mass is a 1.5, that is basically given to the spectral irradiance distribution of the system. So if this three condition will be fulfilled in any places, so your module will be work in the STC condition. So this is the indoor laboratory where we have a taking the flash test of the module. So this is the layer where we have put the module, and with the help of this the lighting the halogen lamp, we will just taking the IV characteristic of the module. The another condition in the STC is called to the NOCT. The NOCT is basically the nominal operating cell temperature. The in a nominal operating cell temperatures, again the three condition. In the NOCT, the irradiance is 800 watt per meter square. The temperature is 40 degree, and in the air mass in the NOCT we take the wind speed. So in the NOCT we take the wind speed around 1 meter per second. So in the upcoming slide we will discuss on that particular condition. So this is the flash lamp, the induced quicksand simulator, which is basically used for the taking the IV characteristic of the module. Now this is a typical example of the IV characteristic, and this is the two parameter. One is the x-axis and another is the y-axis. So in x-axis we taken about the voltage parameter, and the y-axis we taken on the current parameter. When we calculate the IV characteristic, so this is the format will be given to the IV characteristic of the module. Now, so all the module are working to the MPP condition. So suppose that is a P maximum condition, and that will be come to this particular point. So what you do exactly here, you just draw the two lines. One is the vertical and another is the horizontal. So the horizontal line which is come to the y-axis, that is called to the IM, that is the maximum current. And the vertical line which is come to the voltage range, that is called to the VMP, that is the maximum current. So whenever you purchase a module, so you have find out this type of data. One is the Pmax, another is the ISC. The ISC means short circuit current, the VOC means open circuit voltage, Imax the maximum current, Vmax to the maximum voltage. The FF is the most important thing, is the FF. The FF means the fill factor, and the fill factor is the basic criteria. Whenever you choose the good quality of the module or the cell, your fill factor value will be lie around 0.7 to 0.9. Means if your fill factor value is come around 0.7 to 0.9, so that's the meaning, and that's the case your module will be work in a very sophisticated way. So this is the major condition. So with the help of fill factor, you can also determine your module quality is good is bad. So if your fill factor value is lie between 0.7 to 0.9, means your fill factor is working in a very well condition. Then you have the series resistance and the shunt resistance. So the value which will come to the current prospect, so this will be depend to the series resistance. And when we talk about the voltage, so with the help of that will be called to the shunt resistance of the parameter. So whenever you doing to the any IV characteristic of the module, so these all are the parameter are the important to the consideration on the output. Now, when we talk about the simulator, the sun simulator, where we have a taking to the IV characteristic. So basically, there is the three different type of sun simulator. Is visible? Yeah, can it is visible now?
Yes, sir. Yes, sir.
Yeah. I think there is some issue of networking. Sorry.
Yeah, your voice.
Now it's coming is good. Now my voice is good, clear.
Yeah, yes, sir.
Yeah, yeah. So this is the classification of the Sun simulator. So in the Sun simulator, they classify in a three different way. One is the Class A, Class B, and Class C. And this Class A, Class B, and Class C simulator will be defined to these three different value. One is the spectral match value, then the non-uniformity, then the temporal stability kind of thing. So what is the meaning of the class A? If you the spectral mismatch is the plus minus 25%, the non-uniformity is the less than 2%, and the temporal stability is also the less than 2%. So if this type of condition will become, so your the sim simulator will become in a class A basis. If you're talking about the class B, so your spectral match will become around plus minus 40%, the non-uniformity is less than 5%, and the temp
Hello, sir, Yogesh sir. Hello. Sir, Yogesh sir, you are muted, sir. Hello. Yogesh sir, please unmute, sir. Dear participant, please just 1 minute. Hello, Yogesh sir. Your participants, please wait. Sir again going to reconnect. Maybe some technical issue.
So this is audible from your end?
Yeah, sir. Now it is audible, sir.
Yeah, what happened? I think some network issue.
Maybe, sir. Here, fine, sir. From your end, I think some issue.
Yeah, maybe some problem in my network. But now it is okay.
Now it is okay, sir.
Yeah, so we
Please
will
continue.
discuss about the average efficiency of the different type of module. So there is a different type of technology available in the
Hello?
module like the sun power. The
Hello?
efficiency is around 20.4%. Then we
Evening.
have the HIT, the efficiency is around 19.5%. Then we have the monocrystalline module, the efficiency is around 16.5%. Then we have the multi-crystalline technology, the efficiency around 15.2%. Then we have the CIGS. The CIGS means the copper, indium, gallium diselenide, and the efficiency in that particular module is around 13%. Then we have the CDT module where the efficiency is around 11%. And then we have the amorphous silicon, the efficiency is around 8 to 10% on such type of module. Now, our next topic is the insulation resistance and why it is important for the electrical safety test. So the purpose of the determine whether a module has the sufficient electrical insulation between its current carrying part to the frame or the outside world. So this is the insulation resistance. How can we do the insulation resistance? So that is a call to the maker also. So the equipment is basically called to the high voltage insulation tester, and that's the equipment made by the Fluke. The model is a 2956AA. The input is 230 volt AC, 50 to 60 hertz, and the 5 ampere the current. The output is 0 to 500 volt DC, and that will be connected to the mega ohm around 2 to 10,000 at a 500 volt DC, and 2 to 1 lakhs to the 5,000 volt DC. So this is the instrument that is a call to the maker. So for the one point we will connect it to this particular frame and another the diode in, and then with the help of that we will taking the insulation testing of the module. Now this is the different type the insulation test. So for the sample one we applied the 1000 volt, and then we got the resistance is around the 10,000 ohm, and our leakage current is a 0.1. Then again we will define the 1000 volt, and that the condition is the resistance the 4400, and the leakage current is this one. So this is the different type of sampling where we have a getting to the applied voltage, and if you applied the voltage more than 10,000 volt kind of thing, so the resistance of the 120, and that a condition the leakage current in a very high in that particular condition. Now the similarly we will doing to the weight leakage test to evaluate the insulation of the module under the weight operating condition like that raining condition, the fogging condition, the dew condition. So that particular condition we will also cross check your module will be working in the proper on that particular condition, and the module will be not given any current and anything. So for that kind of things we will require to the weight leakage current kind of thing, and for that the weight leakage current we require the equipment like a water container for the weighting of the module. Then we will taking the spray equipment to the keeping the module the weight during the test. Then we have taking the insulation tester to measure the insulation resistance, and then we will require the test requirement a water weighting agent solution melting the following requirement, which is the resistivity around the 3400 ohm centimeter the lace, and the surface tension will be around 0 to 0.3 nano per meter or less, and the temperature on that particular condition is around 22 plus minus the 3 degrees centigrade. So this is a test setup. So how can we decide it to the test setup? First we take a water in the container for the weight of the module, then they spray the equipment to the keeping the module weight leakage testing, and during the tester to measure the insulation resistance on that particular condition. So with the help of that we will find out the weight leakage insulation current on that particular condition. Now the another important parameter in the module is the temperature coefficient. So there is a two different type of the temperature coefficient. One is the positive temperature coefficient and the another is the negative temperature coefficient. So what is the meaning of positive and negative temperature coefficient? So we have a one formula, the RT equal to R naught into 1 plus alpha T. So what is the meaning? If you increase the temperature and the resistance is also increases, so the things will be called to the positive temperature coefficient. And when the temperature will be increases, your resistance will be reduces. So that is the call to the negative temperature coefficient. So now when we're talking about the solar modules, the basically in IV curve there is the three major parameters like the power, current, and voltage. So when we're talking about the voltage, the criteria. So when we're taking the voltage, so the voltage temperature coefficient is a negative. So what is the meaning of the voltage temperature coefficient is a negative? Means if the temperature is high, suppose that if the temperature is 15 degrees, 60 degrees centigrade on the module temperature. So on that particular condition, your voltage will be minimized on that particular condition. So what is the meaning of that? The meaning is that they have to reduce to the voltage of that circuit, and when they increase the temperature, the voltage will be reduced. So that condition is called to the negative temperature coefficient. Similarly, we have the current parameter. So in that current parameter, when we increase the temperature, the current value will be increases. So that's called to the positive temperature coefficient. Now we have the power. So the power is basically defined to the two component. One is the voltage and current. So in a voltage, the negative temperature, and the power, the current is the positive temperature coefficient. So if you overall multiply with the positive to negative, so it will become to the negative. Means if the resultant of the negative temperature coefficient. So this is the three different type of the things. So one is the coefficient is the short circuit current, which is represented by the alpha. The open circuit current VOC will be represented by the beta, and the maximum power is called to the sometime is denoted with the gamma or sometime in the delta. From the module measurement, the coefficient will be determined to the different conditions. So for that temperature coefficient, we will require the environmental chamber and the sun simulator. Now this is the three different conditions. So you can find out the temperature coefficient and voltage is going to the negative because it's already given that there is a negative temperature coefficient. When we talk about the current, so the current is the positive temperature coefficient, the value. And when we talk about the power, so if you multiply by the current and voltage, so the resultant output will become to this way. So this is the graph will be going to the downside, means this is the negative temperature coefficient, and the graph will be going to the upper side, that is the meaning the positive temperature coefficient. So here in this graph you can find out the temperature, the power graph, and the voltage graph is coming to this downward. So this is the negative temperature coefficient, and for the current the value will become the positive. So that's why the temperature coefficient of the current is the positive value is here. Now this is a different technology, and the alpha, beta, and gamma is also different to different technology. If you're talking about the monocrystalline module, so the current temperature coefficient will become around 0.0438%. So beta is basically the beta is basically the voltage. So the voltage temperature coefficient is basically come around 0.337%. And the another parameter is the gamma, so it will be working around minus 0.4408. Similarly, if you're talking about the multicrystalline technology, so there is alpha, beta, and gamma is a three different values. So in alpha value, it will become around 0.0466. The beta is, and the gamma is come around minus 0.346. Similarly, if we have a taking of the amorphous silicon, so in amorphous silicon, the alpha value will become around 0.0985. The gamma value, sorry, the beta value will become around the minus 0.294, and the power temperature coefficient will be coming around minus 2.34. So this is the different type of thing. Now the interesting point is here. The thin film technology, if you go to the CDT, the lower temperature coefficient. So if among of all the temperature coefficient, the CDT is the lowest temperature coefficient. So what is the meaning that if you are putting the CDT module in a high thermal condition like the Rajasthan condition, so definitely the CDT will be give to the more power as compared to the another type of technology, because if you putting the monocrystalline technology if you're putting the monocrystalline technology in the Rajasthan area, so you can find out the temperature coefficient is very high, and that's the meaning the degradation will be happening in a very fast rate. So the technology selection, the module selection will be also depend to the site and location, because in India has a different climatic condition, and each climatic condition the module will be so things, or anyway you just cross check to the condition, what are the condition will be coming to the different locations. So that is the major value, and that is the majorly defined to the condition of the different parameter. Now we have talking about the nominal operating cell temperature, and that is a call to the NOCT. The NOCT is basically the outdoor condition. So whenever our module will be putting in a outdoor condition, so the module will be always follow to the NOCT condition, means the nominal operating cell temperature. Now, what is the major condition on that particular NOCT? So in NOCT, we will just take the tilt angle on that particular location. So you already aware that your module will be always facing the south, and in a true angle, whatever the latitude is depend to there. So the first is the tilt angle is there, and the 45 degrees centigrade for the horizontal to meridian. Then we have the ambient temperature. So that ambient temperature will become around the 800 watt per meter square. The temperature of the module will become around 20 degrees centigrade. And if you're taking the module temperature, so if the module temperature will go around 40 to 45 degrees, because there is a one difference between the ambient temperature and the module temperature. So what is the meaning that ambient and module temperature? Ambient meaning, so if the outdoor temperature in the 30 degrees centigrade, so definitely your module will be working around the 50 or 55 degrees centigrade of the temperature. So that is the condition. With the help of that, you can define to the NOCT kind of thing. So in NOCT, the first condition, the total irradiance will be come around the 800 watt per meter square. Your temperature will be also come around 20 degrees centigrade. And the third condition, the wind speed is 1 meter per second is applicable on that particular case. So there is a no electrical load or the open circuit. So this type of condition is called to the NOCT condition. So now how can you define to the NOCT? So this is the formula where we have defined to the NOCT condition. So we have the NOCT means nominal operating cell temperature equal to, this is the T, this is the junction temperature, means module temperature minus the ambient temperature plus 20 degrees centigrade. So whatever the module or ambient temperature, the difference is there. So that is the come to the NOCT temperature on that particular condition. Now the NOCT can be used the system designer as the guide to the temperature at which module will be operated in the field, and it is therefore useful for parameter when the comparing the performance of a different module designing. So that is the two different concern is required is there, and this is a universally applicable to all the PV module in the NOCT and the NOCT condition. Now, if you want to take the value of the NOCT kind of thing, so you have a required some equipment, and that equipment is called to the outdoor equipment. So for the defining of that equipment, you require to the pyrometer, you require the ambient temperature. So the pyrometer is basically useful for the taking the data of the sun intensity, and with the help of the pyrometer, it's always required that each day or the each week we will just clean your pyrometer, because if the sensor will be coming in under the dust condition, it will be not accumulated to the power output. So that's why the cleaning is important. Apart from the pyrometer, you require the ambient temperature sensor, which is the calculate the ambient temperature in the outside. Then you will require a cell temperature sensor. So the basically cell temperature sensor will be sensing to the cell temperature, and then you will require the data acquisition system for the wind speed and the sensor. So whatever the wind speed will be coming on the site, so with the help of that particular the data acquisition system, we will also do the wind speed and other things. So this is a small setup where we have a getting the NOCT. So this is the 45 degrees and 45 degree of the tilt condition. We have taken the two different modules, and this is the tower. So there is the ranking, and in this particular point, this is the anemometer. The pyrometer is near on the structure. You can find out this is the pyrometer. This is the anemometer. This is the pressure gauge. So this type of instrument is required to the system. So these are the important on the NOCT condition. Now, when we talk about the comparison value, so if you're talking about the NOCT in the monogauge line module, it will become around 47. For the multi-gauge line module, it will become around the 48. The amorphous silicon, because the temperature is low, so that the condition is come around 38. The CDT, it is around 45, and the CIES is around the 40 is the NOCT value on that condition. Now, this is the important the things. Now, what is the effect happening in the low irradiance? So, how can you define the low irradiance if the irradiance is less than 200 watt per meter square? So, the objective is to determine how the electrical performance of all the module, which varies to the load the 25 degrees centigrade, and the very low kind of thing is there. So such type of the things is called to the low irradiance parameter. Now the performance of the low irradiance is evaluated available from the simulators, and the setting from the 200 watt per meter square. So this is a different type of the scenario. And if you see this graph is very carefully, I will give you the 1 minute time to you. So this, if you see this graph, what are the things you observe in there? Can anybody tell me what are the things you observe in this table, in this graph? Anybody please unmute yourself. So what happening in this graph? Can anybody tell me what is the effect of the low irradiance happening on this graph? Okay, no answer, so there is no issue. So you can find out from there. So you can find out the different intensity. The current value will be different. So in the 200 watt per meter square, your current is this much. The 400 watt per meter square, your current is this much. So 600 watt per meter square, your current is this much. And 800 watt per meter square, your current is this much. And the 1000 watt, your current will become 3.0%. And this is the IV characteristic of the module. Now the outdoor exposure as the irradiance test. So the purpose of the module ability to withstand to the outdoor conditions. So that's why we have required to the outdoor exposure test. So in IC 61215 required the degradation at the maximum power Pmax not to exceed the 5% in the initial value. This is the first point. The equipment is basically required in the outdoor test bed in the mounting of the module, the pyrometer, the temperature sensor, the data acquisition system, and the arrangement of the module on that particular output. Now, the another important testing is the bypass diode, and the bypass diode is an important parameter on the module. So, why we use the bypass diode? Because it will be avoiding to the shadow effect on that particular module. Because sometimes some leaf, the bird dropping, or some to the module condition. So that's why we are using the bypass diode in the thermal testing. So what is the objective from the bypass diode? To assess the adequately the thermal designing and the relative to the long-term reliability of the bypass diode for the use to the terminal and the effect the module, hot spot and the susceptibility of the system. The major equipment is required. The environmental chamber for the heating of the module is around 75 degrees centigrade plus minus 5 degrees centigrade. The temperature probe of the measuring and the recording the time of the module is around the plus minus 1%. The power supply to the applying the current equal to 1.25 times to the STC condition, and the module test under condition means the monitoring flow the current through the module throughout the test. So these are the condition will be the basically useful for the bypass diode. Now the hot spot in the endurance test, and this test is basically used to the ability to the module which is stand to the hot spot heating effect, and like that the solder metering and the discoloration or deterioration is the encapsulation. The effect could be the provoked in the crack, mismatch cell, interconnection failure, and the partial shadow kind of things, or the swelling of the module. So with the help of that, the hot spot you can find out. So for what is the equipment was required for the hot spot, you just required the opaque cover of the test cell shadow, the 5% measurement will be done. The IR camera, the sharp thermal requisition at the 76,800 pixel and the 1200 the 1200 degree centigrade. The temperature accuracy is a plus minus 2%. Now the next thing is the UV proceeding test. So what are the major the things will be done here? So for the prevention of the module with the ultraviolet like the UV, because when the radiation is falling to the earth, so there with the basically using to the three different region is there. One is the ultraviolet region, another is the visible region, and the third one is the IR region. So what are the things? So for the module, so the module will become the module availability or the module exposure, the maximum intensity will be falling in the system is around in a visible region. So how can you define to the visible region? So visible region will be defined in a different way, like that. In a visible region, the intensity or the wavelength of the module we will come around the 300 to 700 nanometer. So if the module the nanometer is below to the 300, the intensity or spectrum is called to the IR region, and above the 700 it is come to the infrared. So now the UV preconditioning test is important from there, and with the help of that UV production, the preconditioning test, we will go for the thermal cycling test, the humidity freeze test, the identify those the material to the adhesive bond and the susceptibility of the UV degradation. So these all are the things we will require is there. So for the UV exposure system, to control the temperature of the module which the irradiated to the UV is around 280 to 380 nanometer, and it will be work in the 60 degree centigrade in that particular system. Now the temperature probes for the measuring of the recording to the temperature in the module, then you require to the UV measuring the radiation. So this is a typical example of the UV chamber. So this chamber will be work in the UV radiation, and the UV radiation is the very harmful for the human eye as well as the module. So that's why we will just cross check any UV light will become around 280 to 385 nanometer will be affected on the module or not. If the module is affected, so there is definitely the degradation will be coming on that the picture. Now the UV preconditioning in the irradiance test, so similarly the UV preconditioning test, the purpose to identify the material that are the susceptible to the ultraviolet degradation before the thermal cycling and the humidity free cycle to the perform of the system. The IC 61215, so basically is the requirement to subject the module parameters and the total irradiance on that particular condition. And now when we're talking about the IEC 61215, the requirement of the different type of the UV irradiation, like the 1500 kilowatt hour per meter square. So there is a two different section, UVA plus UVB, and the region is around 200 nanometer to the 400 nanometer with at least the 5 kilowatt hour per meter square of the system, and the 33% of the UVB region and the 280 nanometer to 320 nanometer. So which is the maintaining the module is a 60 degrees centigrade to the 5 degrees centigrade. Now the IC 61646, the UV protection, the 3% to the 10% to the total UV irradiation, and this requirement has been harmonized for the IC 61215 by the CTL decision sheet and the 733 within the IEC double ECB scheme. So this is the things is the requirement of that particular cycle. Now we have the thermal cycle, and the thermal cycle is also important of the module. So that determine the ability of the module, the withstand to the thermal mismatch, the fatigue, and the other stress response will be the regulated to the change of the temperature. So that is a call to the thermal cycling. So what are the major equipment is required for the thermal cycling? So one is the first the things is required the environmental chamber with the caustic the temperature control. Then we will require the power efficiency for the plug and the power supply to the current equal to the STC, and this module test in the flow current and the module during the test on the system. So this is the thermal cycling, and that particular cycle, the first the module will be tested to the minus 42 plus 85 of degrees centigrade. So now if you see this graph, so with this graph you can find out to the different value. So in the minus 40 degree, this is the minimum dwell will become to the 10 minutes of the time, and then again it will become to that particular condition. So this particular condition will be happening in a 200 times. So if that will be happening in a to the different aspects. So this is the thermal cycling is the decision, because a lot of the time if you want to use your module in the colder region, so your module will be passed on that particular criteria. If the module is not passed on that particular criteria, so you cannot put your module on that particular region. So that's why we have a requiring to the thermal cycling, and that is important to the thermal cycling to the analysis of the system, and with the help of that you can define to the proper the study on the module. Now the another test is the humidity the freeze test, and this is a determine the ability to the module withstand to the effect the high temperature and the humidity the humidity followed the sub-zero temperature. And this is the equipment. The first is the environmental chamber is requirement with us. Then we will require the automatic temperature control and humidity. Then the multimeter, the monitor the continuity of the internal circuit for each module during the tested. So this is also the important the criteria. And now you can find out the humidity freeze test. So initially that will be the freezes for the 40 degree, and then the temperature will be maintained on that particular condition. So now if you wanting to the freeze kind of condition, so this module will be working the minus 42 plus 85 degrees and the 85 degrees centigrade, and that is the different the criteria how much the relative humidity will be going on that particular condition. So in the first condition, that is around 85% of the humidity, the plus minus 5% is the relative humidity, and with the help of that combination we will making a one different type of graph, and with that the graph we will determine the humidity freeze testing on the system. Now similarly we have a damp heat test, and in the damp heat test we will determine the ability of the module to the withstand to the effect of the long term the penetration of the humidity, and then the equipment for the requirement of the damp heat testing. So the environmental chamber with the humidity and the temperature control is a requirement. Then what are the services will be effective on the module? So this is a kind of the environmental chamber with the humidity and the temperature control kind of thing. Then we have a different type of services, so the services like the temperature coefficient, the plus minus 85%. We have the 5% of the thing. So now the services that the temperature is around 85 degrees centigrade, 85 plus 2 degrees centigrade the temperature in the damp heat condition. Now the relative humidity will always come around the 85% to the 5% of the system, and the test duration will become around the 1000 hours on that particular condition. So these all are the damp heat instrument, and with the help of that you will be test your equipment is the test is so this is the severities is the requirement for the module. So this is the temperature is around 85 plus minus 2%. The relative humidity again the 2%. Then we have the another the criteria is the robustness of the module. So what are the things will become in the robustness, and what is the objective? Why we will require to the robustness of the module? So determine to the termination and the attest of the determination of the body of the module which is stand to the stresses kind of thing. So the PV module is connected to the type C kind of the terminal undergo the stress test condition. So if it is follow to the stress test condition, so means your module are working in a very perfect way. I mean, if something is happening on the module, so definitely it will be some problem is there. So that is the method which whatever with the help of that we will bring the various cycle level of the tensile strength and being will adopted to the system. The equipment is called the grade section with respect to along with the hanging arrangement. Then we have doing the mechanical load testing. During mechanical load testing, we will define to the different things. So the first thing they will require the objective. Why we will require to the damp heat to the purpose of the test of the determine the ability of the module or resistance of the module, which is the snow and the wind and the now, so what are the equipment will be required? The mechanical load tester, which is enabled to the module for his module, the mounted freeze and this will be the basically come to the mechanical load kind of thing. So there is the condition when we have applied the force around 2400 Pascal, and that the 2400 Pascal were come in the uniform in the load around 1 hour the condition, and then we're giving to the front and back leakage current, and if anything will happening, your module will be the damage on that particular condition. So you first is the instruction or so this is the things is required. So the mechanical load is around 2400 Pascal. The uniform load is around 1 hour. So if you are putting the 2400 Pascal load on the system, and it will be work in a 1 hour from the front and back side. So that is that is a call to the mechanical test of the system. So the lot of time you will find out the people are standing on the module. Sometimes the module cell are cracked down on that condition. So that's why we have using to the mechanical load testing, and with the help of that mechanical load testing, we will ensure that your module will be not breakers on that particular condition, because this module is already past the 2400 Pascal the requirement, and it is a uniformity load around 1 hour. It will be work in a proper way, and with the help of that it will be given the output. So this is a typical example of the setup, and with that setup you can find out the thing. So this is a different type of the grill, and you can also find out some module is already attached on the system. So with the help of that, we have the 2400 Pascal, and it will be the uniformly load from the 1 ear from the front and the back side. So this is the example of the mechanical load testing of the system. Now, the health impact is also an important parameter because a lot of time in a rainy season, the hail storming will be happening in the nature, and this hail will be also affected to the module because if the hail size is bigger and it is automatically come to the module, so definitely your module will be damaged on that particular condition. So, what are the things will be come in the hail impact test? So the objective of the test to the assertion the mechanical integrity of the PV module during the hail impact. So now, so what are the condition is the requirement for the hail impact test? So there is some test condition like the you have a required the circular ice ball which we have the 25 millimeter of diameter and the bombard with the a small velocity from the top the top places. So this is the circular for the bell, and with the help of that you can also find out the hail impact of the system. So you just make the some ice ball which is the diameter of the 25 dia and the velocity will be around 23 meter per second. So if you are making to the test condition kind of thing and you are making the 23 milli per second on the velocity and the bulk is around 25 millimeter of the diameter. So such type of test will become to the hail testing, and this is the example of the hail testing. So if you see that so the first the ice ball will become on that particular ring, and then the ice ball will be dropped directly on that module. So if the module something is having this is the things required for the hail impact. Now the another the important device is called to the light socking kind of thing. So in the light socking the device we will also do to the preconditioning kind of thing. So if the outer temperature is not good, there is a no intensity kind of thing. So such type of the things we will require to the light soaking principle, and with the help of that light soaking the system we will do into the proper IV characteristic of the module. So in that particular condition, not put to the so this is a light soaking the thing. So the stabilized to the electrical characteristic of the thin film module, like the simulated the solar radiance and what are the equipment is required. So the major equipment is required like the suitable reference devices with the integrity of the monitoring and the irradiation. The two thermocouple with the accuracy is a plus minus 0.5%. So these all are the things we will cover on that particular the workshop. And now we will taking about the light sucking and other things. So these are the major instrument which is required to the system. But now when we're talking about to the reliability concern and other things, and so these are the different type of testing of the PV module which will be the applicable on the system. So these are the part of the module basis. But now if you want to put up the solar module and if you want to put up the any power plant in your home location or office, so what are the steps is required in there? So whenever we start to the any project, we start from the concept basis. So first we require the concept. Your customer is want to which type of installation. They want to the on-grid installation, they want to the off-grid installation, and they want to the hybrid installation. So what is the meaning of the on-grid? So the on-grid means whenever the system is directly connected to the grid and there is no possibility of the storage and other things. So such type of system is called to the on-grid system. So the another type of system is called to the off-grid system. So in that off-grid system, whenever you require to the battery storage kind of thing or battery backup kind of thing, so that type of system is called to the off-grid system. And then after the third type of the power plant is basically called to the hybrid system. And in the hybrid system, basically the combination of the both type of things. So it is a combination of the on-grid as plus the off-grid solar power plant. So with the help of that, you can make to the hybrid solar power plant. So whenever you start to doing the work, or whenever you want to install to the solar power plant, the first criteria is the concept. So first you talk about the client, and then you just understand what is the requirement of your client. Either it will be go for the on-grid basis, either it will be go for the off-grid basis, or either it will be go for the hybrid basis. So this is the first requirement for the system. The second requirement of the system is the pre-feasibility study. So what is the meaning of pre-feasibility study? So the most important thing in the pre-feasibility study is the shadow-free area. So if you whether you want to install your solar power plant, that is a much more important thing. There is a no shadow will be affected on that particular area. Like that, if you need the small power plant like the 5 kilowatt, the 25 kilowatt, the 50 kilowatt is a small solar power plant, and the system you can also install to the anywhere. So, but whenever you install to the solar system in any location, so you just find out there is a no shadow will be coming across anywhere of that particular location, because if the shadow will be coming on that location, your module will be not working in a proper way on that particular condition. So whenever you install your solar power plant, you always focus that your area will be always to the shadow free area on that particular location. Now the another thing is the third point of the installation of the solar power plant is the feasibility study. So there is a two type of the feasibility. One is the pre-feasibility study. There we have a just judging my location is good, there is a no shadow, nothing is there. Then after we go to the feasibility study, so in the feasibility study, we just cross-check the irradiance, the temperature, the humidity, the wind speed, the local transportation, the availability, and all the things. So with the help of that, once we will find out to the feasibility study also, then after we go to the design and development, and with the help of design and development, there is a lot of methodology are using is there. Like that, if you want to design of any solar power plant, so you can use to the either you can design to the manual method, or either you can design to the simulation based the software. So if you want to design to the 10 kilowatt power plant, the 25 kilowatt power plant, the 100 kilowatt power plant, and that particular condition, you have a required to the you have a required to the manual method. But if you have the power plant is a bigger, like the 1 megawatt and 2 megawatt, 10 megawatt kind of thing. So if the power plant of this type of the range, so that the range you did not define only in the Excel sheet, because lot of time there the visualization is important. The lot of the losses parameter the affected on the module, which will be affected on that the total performance. So this is the fourth part. This is the design and development. Now when we talk about the simulation software, so we have a required to the different type of software. Some software is the free of cost, some software is the chargeable. So with the help of that software, like the free of cost software, the PV Soul, the PV Watt, then the RAT screen, then the SAM. So this is the free of cost software. And whenever you talk about the chargeable software, so the PVSys, the PV Soul, and the Helioscope, the Solaris. So this type of software is the paid version of the software. And whenever you have designing to the solar power plant, so you can choose any one the simulation software, and with the help of that, you can design your power plant. And after that, you finalize the design and development. Then the next part will be come to the construction and the commissioning. So that is the five major part is there. So whenever you install to the solar power plant, so always keeping this 5 point in your mind. If you're the first step is the concept. In a concept, we will go around the on-grid, off-grid, and the hybrid kind of system. The second step, we will go around to the pre-feasibility study, where we have decided to the the condition, the shadow effect, and all the things. Then we will cover the feasibility study, and then the feasibility study we will cross check the irradiation, the temperature, the humidity, and the wind speed. And then after we will discuss about on that particular parameter around the design and development, and finally we make the construction. So this is the important parameter. Now whenever you install to the solar power plant, because in this slide we will see that our efficiency parameter, I will go to the back side. So you will find out that your module efficiency is very less on that particular condition. So how can you define your module will be working in a big way if the efficiency is the 10%, 12%, another thing. So how the module is the beneficial to using to the ground surface. So for this is only the material efficiency, means if the 100% power will be falling on that particular cell or technology. So this means this technology like that the multi-crystalline technology only give the 15 to 16% of the power output of that particular module. But this is not the system efficiency. So for the system efficiency, we have required the two different parameters. One is the CUF, that is equal to the capacity utilization factor, and the another parameter that is equal to the performance ratio. Okay, so you always remember that this is the two different type of parameter which will be the useful for the determined by the solar the capacity. The first parameter is the capacity utilization factor, and the another parameter is the performance ratio. Now where we have used the CUF and where we have the performance ratio, because when we talk about the CUF, the capacity utilization factor, so the capacity utilization factor will be defined by the total the energy generation from the plant divided by the total the capacity of the plant multiplied by 24 multiplied by 365 days. So if you have putting the if you're taking the performance like the coal power plant, the thermal power plant, the nuclear power plant, the hydro power plant. So this power plant are working the 24 into 365 days, means 24 into 365. But when we talk about the solar is not working in the 365 days, and it is not working in the 24 hours. Solar is only working in the daytime when the sunlight is present is there. If the sun is not there, you cannot generate your solar energy with the help. So now when we talk about the performance ratio, because the solar is not working to the 365 days, solar is only work to the 300 to 320 days, and when we're talking about the insolation, it will become around 4 to 7 kilowatt hour per meter square, means your module will be only worth to the 4 to 7 the kilowatt per meter square of the insolation of that particular area. So now we will discover the new parameter, and that new parameter is called to the performance ratio, and that's why the performance ratio is important to determine to the system. So if your performance ratio, so how can you define the performance ratio? So the value of the formula of performance ratio is the reference yield upon energy yield. So energy yield upon reference yield means whatever the energy you have generated from the power plant and what is the reference yield will be getting from that location. For that reference, the yield, the requirement is the pyrometer of the site, because in that the bottom side we have using to the radiation data. So that's why we have a required to the one pyrometer on that particular location. So this is the two different criteria. Now, how can you decide if that your power plant are working in a well or the bad condition? So if you're talking about the power plant, if the performance ratio value is around 70 to 90%, so that's the meaning your module will be working in a very accurate way. And if the performance ratio or performance ratio value is less than 70%, so that's the meaning there is some problem of your module. So that is the two major criteria. How can you decide it to the module? So if your module is working if your module is not working the 300, 365 day and 24 hours, so that's why we have using the performance ratio, and the performance ratio value will become around 0.7 to 0.9, means 70% to 90%. So what is the meaning of 70%? So means that will be covered the 70% of the area, and the 30% will be going to the loss execution. So the loss, we will already define the different type of the losses will be happening there. So the loss like the cable loss, the thermal loss, the temperature loss, then we have the soil loss, then the module mismatch loss, then the incidence angle modifier loss. So this type of losses will be happening on the system. So these are the things is the important consideration for the PV module and the system designing. So these all are the things from my side. So thank you very much. If you have any question, any doubt from your end, so the forum will be open for you for the question answer session.
Yeah. Thank you, sir. Thank you very much.
Yes, sir. Thank you, sir.
Yeah. I request participants, you can ask any questions. Yeah, feel free to ask any questions. So, sir having a very good experience in solar sector. So, sir also research scientist at the National Institute of Solar Energy. Yeah, please, any questions you can ask.
Yeah, go ahead. No issue. Any question regarding this presentation or outside? If you want to ask anything, so you can ask.
Yeah, anything you can ask, please. So we are very glad that sir is accepted our invitation.
Thank you very much, sir. Thank you very much for giving the opportunity. And I think there is a 50 people in this room. So
yes,
that's a wonderful interaction, I think.
Yes, sir. Yes,
and maybe that I think that there is some network issue from my side. So that time.
Yeah, please, any questions you can ask.
Yeah. I think there is no question from anyone.
Sir, actually, we still remember your visit to BVRIT, sir.
Yeah. So in 2018 also, 2016 also. Okay.
Yeah, in 2014 as well as 15.
Yeah, please share
so
the
we are very. So we are happy to share these photos. So actually, sir is came visited to BVRIT solar plant during All India Solar PV Module Degradation Survey.
Yes,
thank you, sir. We still remember.
And you can also remember those days actually.
Yeah, this is in 2015, sir.
Yeah, 2000. One is a 2014 and another maybe 2016.
Yeah.
Yes,
sir. Yes, sir. Yeah, thank you very much, sir, for your guidance.
Yeah, please share the photograph to me also.
Thank you, sir.
Okay, sir. Thank you very much for giving the chance.
Any participants?
Dear participants, those who are having any doubts, directly interact with our resource person. Sir is willing to interact. Willing to interact you. Thank you, sir. Thank you very much, sir, for your wonderful experience and sharing your experience of industry experiences in this STTP. On behalf of BVRIT, I thank you very much.
Thank you very much, sir, for giving the opportunity here. Thank you.
Thank you, sir. Thank you for your valuable time.
Thank you, sir.
It's my pleasure, invitation. Thank you, sir. Thank you very much.
Thanks
Thank you,
a
sir.
lot, sir. Have a great day, sir.
Yeah, thank you, sir.
Dear participants, already
Thank you, sir.
the FAQ link is posted in this chat box. Please fill it immediately. It's enabled for another 20 to 25 minutes only. Thank you. Thank you, participants. Thank you, Yogesh Singh, sir.
Sure. So can I leave, or any question
Yes,
from
yes,
your
yes,
end you
yes,
can
yes,
also
sir.
ask?
Anything, anybody want to ask anything? Sir, just I have one question, sir.
Sure, sir. Sure. Go ahead.
Sir, are you testing this bifacial module, sir?
Still is not testing the bifacial module, but in upcoming time we will thinking about the same thing actually.
Okay, sir.
Yeah.
Okay, sir. Yeah, thank you, sir.
Okay. Thanks a lot, sir. Thank you.
Thank you,
very
sir.
much.
Thank you, sir. Now, okay, sir, you can leave, sir.
Sure. Bye.
Thank you, sir. Thank you very much.